In this comprehensive video of Tekla Structural Designer, you will learn how to properly analyze and design reinforced concrete slab and its detail. We proceed to design the pad footing as well as strip footings, and then we will streamline the 3D reinforcement of all the structural elements successfully. We proceed to generate detailed drawings of all the structural elements as well as the reports. Stay connected to gain the whole knowledge in this video. You are very welcome, and let us get started. So here is the welcome interface of Tekla Structural Designer software. What you need to do is to create a new project. You can click on File and then New, or use this New tab right here. Click on it, and then a new project is created just like this. You proceed to set the project code. You see Settings over here. You click on it, and then in the setting dialog, UK settings active for now. If you select here, there are other codes here: Norway, Finland. You can also select them, and then you must make it active for you to be able to use it for your design. If you want to import more codes, you use these options of import. You have various codes here, so you can be able to select, like example, span. Click on the OK. You have it span setting. You can click on active. But in this project, we will be considering UK settings, and then it is active already. You go to confirm this code and various additional codes in this provision of design codes. So over here, you can see we have the region, United Kingdom, Euro code, and then we have the action code and the resistance code as well, right here. So other settings you need to do, like the settings of the unit of the structural element successfully, and then you can come to the scene provisions and then navigate to color. Here you can be able to set the members color of the reinforced concrete elements through the concrete provisions, even the steel, and so forth and so on. Other options you can actually exploit right here for the drawings and other provisions successfully. We have done the important settings right here. Click on the OK option. Here we go to the material right here. Click on it. And then in the material dialog, we go straight away to reinforcement. And then Tekla Structural Designer at default have only one class of reinforcement, this 500 class, and here are the available sizes right here. You can add your own class by clicking on this add provisions right here, and then you provide all of these informations, and then you click on the OK options to be able to add it. Likewise, the reinforcement diameter, you can as well be able to add it through these provisions, but we go by this default 500, and then we go by this reinforcement. It's very important that we look at the types. It is going to be loose bar. If you select, there are other options like wire, mesh, but we are going to be going by loose bar here. And then the rib type is going to be type 2. You know, we have plain, we have type 1 and type 2. All right, we go by this. We are good. Click on the close options. Now we want to set the construction level. For the construction level, you need to navigate to the modeling tab, and then over here is the construction level. Click on it. So you have the construction level dialog. Proceed to the insert above. I insert the first one, which is the first floor, second floor, and third floor. So we are going up to 3 stories in this project. Over here where you have types, you see TOF. This is type top of foundation. And if you click in these provisions, you can see XXL, which is structural slab level. You can also see TOX, which is top of steel. So you use these options when you are designing steel member. We select XXL, and then over here XXL, over here XSL. All right. So for the height of the story, which is the space in meters, you see in meters M. So for the first story, it's going to be 3.5 meters. For the second story is going to be 3 meters, and then for the third is also 3 meters, just like this. Okay, so for the source, it is unique. Okay, if you want story 2 and 1 to be the same or to be similar, you need to use this provision. Click here and then select this. So this simply means story 1 and 2 are going to be a similar story. They are not going to be unique. All right, so now we will get back to unique for all the stories. Then over here, slab thickness, all right, is mm. which is millimeters. We provide 160 millimeters for the slab thickness, 160 millimeters for all the floors, just like this. Okay, this is the setting for this construction level. All right, so click on the OK option. We are good. If you select in these levels right here, you see the construction level we created from ST base to ST3 right here. So you can double click on ST1 to actually make it active right here. And then this is the ST base. Likewise, every other story successfully. Okay, so now this is the 3D provisions. If you right click on this, you have some information here. So we'll be going through it. We can also tie the window vertical and horizontal using this particular provisions, but we'll go by this. All right, so now we want to start to set the grid lines. Okay, so before we go into the grid lines, we can navigate to AutoCAD, and then here is the architectural plan that we are going to be considering for this design. And then you can check in the link in the description of this video. You will get this plan just for free. You just have to download it. Okay, now we proceed. If I move this plan upwards, I have already extracted the structural grid lines just like this. Okay, for these presentations. All right, so we are going to be referencing this, okay, for the grid line set out in Tekla Structural Designer. All right, so now I navigate back to Tekla Structural Designer and then get to the modeling tab. You see over here, the grid lines are not prompted. You can see because we are in the structural 3D. All right, so we want to, when you want to set out the grid lines, you have to be at the ST base or at the ST1. You should be at the plan level. All right, so we navigate to this ST base. Now it is prompting. So just select in the small arrow. So in the drop down menu, we use the rectangular wizard to create our grid lines. Click on it right there, and then you have this. Okay, we can move this up just like this. So at first you have the grid names. You can change this name, but we are going by the default. As well as the color, we go by the default. And then the grid line is going to populate from ST base to ST3 right here, meaning the entire stories. Okay, so as we make progress, if you have any question, you can drop it in the comment sections. And as well, you can do well to like the video. Let's go. All right, so we click on the next option. All right, this shows that the grid line is going to start from the origin 00. So you click on the next. All right, so this is all lines, and then this is line style. Okay, there are various styles right here, as you can see. Okay, so we have the dot, but we go by the default anyway. Click on next, and then here is the X directions extent. So for the X direction extent, you have the base right here, the regular and the irregular. Okay, so we are going by the irregular options, just like this. So you can see this is the X. So our dimensions is going to actually be measuring upward, and then the grid lines is going to be horizontal. All right, so we make progress. We navigate to AutoCAD. So here is AutoCAD. So the first grid line, since we are measuring upward, we will go by this one, but I would like us to go by this in that directions. We'll also look at all our column points successfully. Okay, so here we have 4225. So 4225, go back here. So 4225 is supposed to be 4.225. And then we do a comma. The next thing we have there is 3.025. We confirm this. The next thing we have there, do a comma to separate it, and then we have 2.125. All right, so we do a comma again. We still have 3.225. okay, so we do a comma right there, and then we have 2.125. so this is the grid lines for these directions. All right, we go to the next directions, go by irregular. All right, so we now have 2 point, let's go to AutoCAD. Let's see what is there. Okay, this is 2.092. okay, so we get back here, 2.092. we do a comma right here, and then we will have 1.7. okay, that is 1.733 right there. 33, just like this. Let's get back to AutoCAD and check 1.733 and then 4425 right there. Get back, you do a command 44. Sorry, it's supposed to be 0.4.425. All right, just like this. You can see the green line set out. It's just like this. Okay, so we have to click on the next option, next, and then here we go by 0 as the angle. Click on the next, and then this is given a 90-degree rotation. Click on finished. All right, here we go. We have done with our green line set out. We want to start to place the structural element. So the first structural element we'll be placing is going to be the columns. The first concrete column. So click on the reinforced concrete column right here. So over here, this is going to define the extent of the column in terms of the stories. So we have the base level right here, and then we have the top level, which is the ST3. That means this column is going to be connecting from the foundation to the ST3, okay, which is the last floor. All right. So we come down to do some other settings like the concrete class right here. We use this one for this project. All right, the auto design option should be checked right here. So the gravity only should not be checked because we are also considering the lateral loads. Okay, so for the sections, you click in this provision, and then you can be able to expand this and click on new options. So in these new provisions, you can type in your section, which is 225 by 225. We are going to be considering in this project successfully. Okay. All right, having done that, we scroll down over here. We scroll down. You can see the reinforcement. You see the types right here. We have looked at this previously. Okay, another thing you should look at is the alignment. Okay, if you adjust this way, you see the major alignment and the minor alignment. You can make it 0. I will show you what this means shortly. All right, so this particular columns is going to be connecting the ST base and then the top story. So the columns are going to be placed in these provisions successfully. I will release my hand and then I have them placed successfully, just like this. So let us get to AutoCAD and see the ones we are supposed to remove. I know we are supposed to leave this one. We're supposed to get rid of this one and then this one as well. You get them selected and then click on the delete options right here to delete them successfully, just like this. Okay, so let's get back to AutoCAD. If you get back to AutoCAD, you see from here, here, and here, you see this is the column we just placed. So these columns are connecting the base level or the foundations and the topmost floor successfully. Okay, we proceed. So over here, we continue to place the columns. So we click on the columns up over here. Top level is going to be ST2. All right, this is going to be ST2. All right, so we now have to scroll down. I'll scroll down the same sections. Everything is the same. So now I will do a window over these provisions to have the column placed. So we are going to be removing some of these columns right here. So I'll have to escape first from here. Let's get back to AutoCAD and see the one to removed. Okay, we have all of this. We don't have it here. Okay, come back here. We don't have it here. All right, so you have to delete this one. Okay, option. All right, come back here. We don't also have this one. This one is not there. Okay, so over here, remove this one as well. Click on the delete options from here. Okay, we are good to go now. So this is the base level. Okay, we have already enabled the ST1 level. I wanted to show you something about the alignment. Okay, so for the alignment, you see these columns are not properly centralized along the centroid of the grid lines. Okay, so what you need to do if you want to actually centralize these columns, you just have to select it. So in these provisions, you come to where you have an alignment. Okay, see alignment, this one expanded, so you can see that the major snap level is this, and then the major offset is also this 0, and then so yeah, what you just need to do, change this place to change it to center, and then yeah, if you change that to center as well, you see this has moved to center successfully. So you can always set this and then place your column if you want all your columns to align. Okay, but we are going by these provisions going left like this. Okay, so I've shown you that. We proceed to place the structural beam. Okay, for the structural beam, we will navigate to the first floor because we have the beam at the first floor. So this is the first floor level. Okay, so click on the beam right here. So you scroll down to do some settings for the beams. Every settings, you leave them at default, all of this. So come over to the sections of the beams. Select on these sections and then click on the new and edit. So here is the section. We go by 225, sections by 450 as the depth of the beam, just like this, you can see. So this is a rectangular beam. You can also create other section of beams right here, but we go by this for now. Having selected all of this, you come down for the reinforcement. You use the same reinforcement successfully. All right, so now we want to start to place the beams. So I can do a window over these provisions to have the beam placed right here, just like this. I can do a window just like this to have it placed right here. I need a beam to connect all of these provisions just like this, you see. So I need a beam as well here. So you can always just do a window just like this to have it placed successfully. So if we were using a kind of similar levels, as we place a beam here, it's supposed to appear at the next floor. But we are using a unique level, so it is only at this level this have taken place. All right, so I will click on the escape to get rid of the command. In Tekla Structural Designer, you always click on escape to get rid of the command. All right, so we double click on the ST2 to actually have it active. You can see nothing is here, so we need to now start to place the beams as well right here. So we select right there, and then it comes, you use the sections we selected, and then everything at default. You can see there's not much to set to actually change here. This is nominal cover for the beam. Okay, the concrete cover for the beams is 30, so you can make changes if this is not 30 in your country. All right, so now just have to do the same thing, a window just like this to have the beam placed just like this at once. You see all the provisions, we have beams now. So now we navigate to the ST3, which is the story 3. I do escape on the keyboard to get rid of the command and double click right here to go to ST3. So ST3, see the area where we have the beams right here. So click on the beams and then scroll down and then confirm the settings right here. Everything is good. You do a window from here. You see you have it placed successfully. You know, this area is where we have the staircase. Okay, so after which you can go to the 3D to actually build the structure. You see what we have right here. Okay, so navigate to the ST1. We want to start to place the reinforced concrete slab. Okay, so now for the reinforced concrete slab, we are going to be using the slab on beam. This one, you see. If you select here, there are other options for reinforced concrete slab. This program can design precast as well, steel deck, timber, and other structural elements. You see, so we use slab on beam. Click on that options. So once you click on option for slab on beam, you know the major concern we'll be looking at is how to actually design the reinforced concrete slab properly. Okay, so this starts from now. You have to pay a close attention to this particular area of the reinforced concrete slab successfully. Okay, let's see. This is the property of the slab on beam we just selected. Okay, so now if you scroll down right now, I want to show you something very important. The reinforcement, this one, expand it. You see. So now scroll down and then you have to make sure that this reinforcement tab is loose bar. If you select these provisions, you have loose bar because that is what we selected in the settings. So make sure you follow up the settings. Very, very important. And then the bar size is 6. That doesn't mean anything. Okay, that will be changed after analysis, or you can change it here, but it will not really affect anything. But after the building is being analyzed, the right reinforcement will be selected. Okay. So we proceed. This person is 200. Okay, so we can adjust this. Okay, before we run analysis, I will show you how to adjust this successfully. We go down. Okay, for the outside layer bar, you see loose bar as well. Just have to make sure that you have loose bar in all of these provisions. All right, have loose bar is very, very important. Okay, so these are the settings that you need to do. Okay, for the slab thickness, we have already assigned that during when we are setting the construction level. You can see 160 right here. So now you put your hand in the area bounded by the beams right here, click, and then to have the slab inserted just like this. This two-way slab, you can see two-way slab. So select and keep selecting in this provision. This is a staircase provisions I will add in a first concrete slab. Okay, so this is going to actually represent the inclined stairs reinforced concrete element. Okay, so I continue to place just like this. All right, so we have successfully placed our reinforced concrete slab successfully on this floor. You go to the next floor, and then on this floor you go back to the slab on beam as well. Check and ensure that all the settings are good. All right, all the settings are good from here. After which you start to place it. Let's go to the reinforcement again. We don't want to make mistake with another reinforcement type. It's a loose bar. You have to make sure it is loose bar because that will actually helps you a lot in the design of the reinforced concrete slab reinforcement. Is very important. All right, this is good. We proceed. Click here to have it inserted just like this. Just like this, just like this. Okay, we are good. All right, so we proceed to the next level, which is the last level here. You click on the reinforced concrete slab on beam and then place it in this provision. So we are good now. Go to the 3D. This is what we get. All right, so we are done with the modeling for this project. We want to start to load these structural elements successfully. So for the loading of the structural elements, we navigate to where we have these loads. You see over here, load. So you just click on that, and then you click on the load cases. Click on it. Here we go. This is load dialog. So here you can add, you can delete loads. So these are the default loads that Tekla Structural Designer actually comes with. So we are going by the default, but I will show you how to add a load. For instance, if you want to add an additional load, you can just select on any of this one. If the additional load is an imposed load, you select on the imposed load. If the additional load is a dead load, select on the dead load. But once you select on it, you come to this position and click on add. So you can see another load case added, and then over here we have a load case also added. So you can give it a name. Come to this provision. The purpose of that load, is it for snow? Is this for wind? You understand? You can be able to make changes successfully, and that is added in Tekla Structural Designer. All right. So now you right click on this, or you delete. You can delete this that we just created because we don't have need for it. Come over here, click on delete. So we have our loads just like this. The load cases just like this. So we are good. Click on the OK options. All right. So now we navigate to the plan view of ST1. We want to apply the load. So I have to come here, see my cursor down here, select on this, make this active. Then you select in these provisions, you see all the load. Okay, you see for the safe weights, and then all the safe weight is being applied automatically on the model. So you start from the dead load. Okay, so click on the dead load right here. We have dead load. So for dead load, we have dead load on the members, which are the block works. All right, so we use the full UDL, uniformly distributed load, the full one. So select it. So over here you have it. So the height of this story, is 3.5 meters. All right, the height of this story is 3.5 meters. So once you multiply the unit weight of the block and the story height, you should be able to have something that look like 10 point. We are just going by 10.4. All right, because 10.4 is actually for 3 meters height stories. All right, so I will key in the load. The direction of the load is very important as well, so you have to check that. So if you select here, you see various directions here. We go by the global Z directions. All right, so after which, now you need to click on the beams one by one to have the loads applied successfully, just like this. So you take your time to click on these beams to have it applied. If there is any beams here that is not a load bearing beam, you can avoid it with the load. Okay, but in this case, I'm going to load all the beams by clicking on them just like this, just like this, just like this, just like this. The beams is loaded successfully. All right, so now we are good on this floor. we go by the next load. We have the service load. The service load, we are going to be applying it on the reinforced concrete slab. All right. So now over here, we are going to change this load. This is service. All right. This is service, and then we use this slab options. Okay, see panel load. So you use slab, click right there. So over here for the service load is 1 kilonewton. So you just select on one slab and it will be applied on all the slabs successfully, you can see. Okay, if you want to see this in 3D, if you go to 3D right here, and then you notice that you are not really seeing it, but come to this provisions and activate the service load. You see the service load right there. It's been applied successfully. If you also activate the dead load, you also see the dead load being applied on that floor successfully. So we'll also apply it on the next floor. Okay, so go back to the plan view. We need to apply it, the imposed load also on the ST1. Okay, so you select impose right here, click on the escape to get right on the previous, and then for the impose is going to be the purpose of this structure. The structure is a residential structure, so the imposed load on it is supposed to be 1.5 kilonewton per square meter. So click on that. So over here the global direction is Z, and then this is 1.5 for the imposed load. So this is a floor load. So I click on the floor to have it also applied successfully. We are good on this floor. All the load has been applied successfully. You get to the ST2 and then you proceed, activate the load, that load, and then you use the full UDL. And then over here, you key in 10.4 right here. You select on the beam members to apply the load. This is a wall load on the beam member. All right. You have it applied successfully. So you have to do all of these things correctly. Okay, if you fail to do them correctly, you have issue with Tekla Structural Designer giving you the required result. Okay, so we are done with this. We escape. You click in these provisions, the service load. You use the slab right here. Over here we have 1. Select it to have it applied. Impose load. Escape. Click on the slab as well. Over here 1.5, you see, and then you click right here to have it applied as well. Just like this, we are good. Go to the next or the last floor. Over here, activate the dead load for the beams, full uniform load. Over here you have 10.4, and then select it successfully, just like this. You can see, select on the beams to have it applied. Okay, we are good. Escape from this command, click in these provisions, activate the service load. This is a slab load, and then the value of the load is 1. Apply this successfully. Escape again, activate the imposed load from here, and then click on the slab, and then the value of the load is 1.5. all right, just like this, and then you click to apply it. Now go to the 3D, just like this. You see the load, you see. So now this model has been loaded successfully, you see. So we are good to go now for the analysis of this model. Okay, but if you want to see the load value, you can come to the scene content, and then if you come down, you see load right here. You see loading. So left click on this and click on text here. Click on OK. You see. So here are the value of the load being applied on this model successfully. I want to ask you at this point to hit on the like button, and then if you are here to subscribe to our channel, can they subscribe to this channel as we bring you more useful content. And I'm also inviting you to join our YouTube membership. Click on the join button right there to join our YouTube membership. Thank you. Let us make progress. All right. So now we proceed. We want to start the analysis. We don't want to apply wind load on this model. All right, because this model does not require the wind load. Okay, if you want to learn how to apply wind load in Tekla Structural Designer, there's one of the video I did on this channel that explained how you can apply it wind load successfully using Tekla Structural Designer software. All right, so now we make progress. For the analysis, you have to navigate to the analysis tab. But before the analysis, we need to carry out the loading combinations. Okay, so for the loading combinations, you come to the load cases right here, and then you click on the combinations right here. So in the combinations right here in the dialog, you navigate to the generate You can add, okay, you can add manually if you want to add your combinations manually, all right, but we'll use the generate options based on the code we selected. All right, so now click on the generate. So we have this combinations generator, you see, dialog. All right, uncheck some of this. We don't need all of this for now. We use only this table. All right, and then the scenario is going to be final scenario right here. Click on the next options, and then you see the dead load and the imposed load factors of safety. All right, based on this code we are using, we are using an arrow code, and then these are the factors of safety for the codes is being applied successfully. Click on the next options right here. So you click on next again. So we have these provisions. Okay, so for here you have to have this box checked successfully, so you can be able to create the 4 layers of loads, okay, as required by the code successfully to be applied on this model. So click on finished. You see you have this successfully. So these are her loading combinations. So after you must have created a loading combinations just like this, you can proceed to the envelopes. So envelope have to combine all of this load in one place, and then you can apply it on the model for the design. Okay, click on the envelope right there. So you click on add envelope. So you can give an envelope a name, but I will go by this envelope. All right, I click in these provisions. Here are all the loads. I move them to the envelope using this provision successfully, after which you click on the OK options. So we are good now to carry out the analysis of this structure. Okay, so now for the analysis, we proceed to the analysis tab. You have to do some analysis settings, like select the type of analysis you want to do. All right, go to the settings right here. So now you see we are on building analysis. We have the grillage chest down. We have the FE, which is the finite element chest down. You have the modal analysis and the RXA. You run this analysis when you are designing for seismic. All right, it's when you are designing for seismic you run this. Okay, so we start from the first order analysis right there. You get that selected. Okay, you can click on save. Okay, right here, and click on yes options, and then click on okay. All right, so on the analysis tab, you see over here we have analyze all statics. You can see 3D only statics. So this 3D only statics enable you to carry out the analysis of the finite element and the grillage chest down. That is when you are designing something like a kind of a do I call it a floating foundation or raft or slab raft foundation. You will have to run that, and we will do that in this video. All right, because one of our concern of this video is the strip foundation. So you need to run the 3D only statics analysis. Okay, so now we first look at the analyze all. So analyze all, click on that. So once you click on that, this project will be analyzed by Tekla Structural Designer, and then analysis is successful, you can see. And then we are not seeing any result. For example, if you click on the result, you are not really seeing the result showing, but you have to come to the combinations and select the load combinations like this one. This will actually show you the result. All right, so now we can look at the forces in the member. You see the axial forces I've already shown right here, and then you can also look at the moment in the measure. So here is the moment. Okay, and then you see we can still run animations on this. All right, if you wish, if you click on the deflections, where's the deflections? Is this one? Deflections. Good, this one. You can see the deflections of the model due to load. So with these deflections, you can right click, and then you'll be able to carry out some animations to see the behavior of the model. As you can see, you can scale it using these provisions successfully. Click on the close options. If you want to see the reaction generated based on this, you can actually activate these ID options and then click on the reactions, and then you see your reactions being generated successfully, you can see. All right, so other things you need to check are other forces that is acting. We have the shear force on this model and the rest of that. And then if you check here, you see we have FE chest down, we have grillage chest down. Okay, under service we have this. So we can also check this under strength successfully to see the load including generated at the foundations of this model successfully. Okay, so these are the things we need to check for now. So we are at 3D. You can also right click on this and then you come to this provisions, change it to the structural view. We'll have this. Okay. So analysis is done. I want to be running this 3D only static. I click on that. So that will also run successfully. And then we see the result as well. It's very, very important. Okay, so having done all of this analysis, we don't have anything much to check right here. This provision is for design. All right, some of this provision is for design. Okay, so now we navigate to the structural view right here. All right, we get straight away to the design options. So before you design, we need to do some settings as well. You click on the settings right here. For the design settings, we have some important settings to do here. Over here where we have custom place, you can see our slab right here. So here you can be able to change the minimum loose bar you want to use on the slab. I want to use 12 as the minimum, and the maximum is 16. The minimum clear spacing is 10. So all of these informations are very important for you to be able to properly design your reinforced concrete slab. Okay, so the same thing applicable to the beams as well. For the patch, for the patch, you will be applying the patch. You see the default patch right here. Okay, for the foundations, you come to the foundations, you come to the mat foundations, and then you see the reinforcement layout as well. We have minimum loose bar of 10, so you can click on this and be able to change this bar to 12, and then click on the OK options right here. You see the country is UK. The country is UK, so the reinforcement we are using is based on the UK standard. Okay, so for the isolated footings, the same thing, we use 12 minimum, and then we use 16 maximum for the loose bars. Okay, so every other settings here, we're not designing pile for now. Okay, we don't have wall in this structure. We have reinforced concrete columns. Select in that provisions. Okay, so you can see minimum bar and then minimum bar size is 10. So you see we go by this minimum and this maximum successfully. All right, can check the beams detailing settings for that. Detail settings, you can leave this at default. All right, leave this as default. We go by this reinforcement, but you want to provide ties through floor depth for internal columns, you can use these options, and then or this option of this tie type you can use successfully. Okay, now for the beams, you have to also check the maximum and minimum. For beams, I will be using 16 for the minimum bar, and the maximum is going to be 25. All right, so these settings are good. Okay, now we are almost done with the settings. We scroll down. Let's check if there's other settings. Okay, you see this group design group options. Select in these provisions and then make sure you check the structural element you wish this program to group for you. Okay, so I want it to group isolated fitting. I want it to group concrete columns, concrete beams. All right, so I've done that successfully. Then whichever provisions do we need to look at? Design reporting forces, we don't have need for that for now. We are good. Click on the save option and then click on the yes option, after which click on the OK. So we proceed. We want to run the design of the structural element. So here we go. We come to where we have design all statics options. All right, so you click right there. So once you click, the design will be carried out successfully in just some seconds, and then everything is done. Boom, you see all of the structural element as per design, the beams and the columns successfully. So you can now have to check these beams to see the interactions. Okay, select on it, right click on this beam, and then navigate to check member statics. So this has been designed, so you need to check. Click on this check options to have this check dialog just like this. So if you select any of this, you can be able to see the informations of this design successfully. You can see here we have the 3D building analysis, FE, just down, everything has been carried out successfully on this beam. So the load transfer has been done properly. Okay, click on the close options. Also check one of the columns to confirm the design statute. So check member static. You see everything as past design as well. You can see the utilization ratio. is very comfortable. And then you will have 4H16 bar, and the analysis type, the section is also here. So if you select in these provisions, you can see that you have all the required informations. Okay, so click on OK. So if you want to make changes to the sections, all right, you want to make changes to the sections, you can actually be able to select the sections, right click. This time around, you're going to be using the design member options and not check. All right, design member options, or you can use the interactive design options. Click right there. So in this interactive design options, you can be able to see detailed drawing options. All right, so if you select it on any of this, you have this expanded like this, so you can see the beams arrangement, and then you see the bar size right here. So with this, you can be able to make changes to this bar size successfully. If you select in the stirrup provisions, you can see the stirrup selected right here is H8, so you can choose to use H10. So this is how you carry out your interactive design in Tekla Structural Designer. If you want to view the drawings, you can click on detailed drawings. So once you click on this will open the detailed drawing in AutoCAD very fast. You can see here is the detailed drawings, but we get here where we produce all the drawings in this video, because this video is a complete video of Tekla Structural Designer for full building design. So stick to the video until we get to the end of it. All right, so we navigate back to Tekla Structural Designer. I'll close this. So the same thing applicable to columns. If you select any of these columns now and right click, go to interactive design sections, and then you see the section selected, you see the concrete strength used. Okay, so if you select any of this, you can see this provision expand, and then you see the sections and the reinforcement arrangement. Okay, so by mistake, if you make any changes here, for instance, I take this to H8, you see H8, and then you see everything failed right here. All right, if I change this to H16, you see everything is good right there. Okay, for the tile reinforcement, for the interactive diagram, just like this, everything is very, very good with Tekla Structural Designer. All right, at this point, if you are yet to give this video a thumbs up, I will advise, please help us, give us a thumbs up. Okay, and then if you are yet to subscribe, kindly subscribe, and then let's proceed. Okay, we want to start to design the foundations. No, before the foundations, let us design the reinforced concrete slab. So to design the reinforced concrete slab, we need to get back to the structural view, just like this, and then we navigate to the first floor. You know, we have a slab here. We will design all the slab on this floor successfully and generate the reinforcement. Okay, so now to design reinforced concrete slab, what you need to do, if you select one of these slab, you can do escape. Now come over here and click on the validate to have these validations first. Okay, select on this slab. I'm trying to select on the slab, but it is the slab load that is actually selecting. You see, if I select, it is the slab load. So you can go to 3D. So you can be able to see the reinforced concrete slab. And then if I select on it now, if I select on this slab, you see it's selected now. And then over here, you see the informations. The informations are very, very important. You have to check them closely. Okay, majorly the reinforcement. Okay, you see here we have imposed load reduction. So you can apply an imposed load reduction if you expand here. For this structure, you can apply at least 30% or 20% imposed load reduction. Okay, but we didn't want to apply that. We are going to design this with all of the loads successfully. Okay, so now we make progress. Go to the plan view of this. To design the reinforced concrete slab, you don't need to do anything. Okay, you see these options of slab design. You have to click it to have a design, but by then we need to be applying a top bar. Top bar is applied in Tekla Structural Designer using this option of patch tab. Okay, so if you click this, you see patch column, patch beam, patch wall, patch panel. Okay, so now I want to patch the beams. Okay, because you know the top bar are actually connected to the beams and the slab successfully. So I will select on the patch beam. If I select on the patch beam, and then I click on these provisions, you see this is patch, but I failed to give the extent of patch which is in these provisions. So you can always undo from here. You can see. So now I want my patch to be 1 meter. So if I key in 1 meter from here as the patch and I select in these provisions to have a patch, I patch this. So this will serve as my top bars. All right. So in applying this, you have to actually be calculative. Okay. So I will apply this successfully, just like this. These are my patch. All right. Apply this over here. I wouldn't want to apply it because that provisions is for staircase. I'm not supposed to add this one. Okay. You apply the patch just like this. Just like this. We are good on this floor. So I would like us to apply this patch only on this floor. Every other floor, we may not necessarily have the patch. Okay, but I just want to show us how you can apply the patch successfully in Tekla Structural Designer. All right, so this is how the patch is being applied. So after which you can click on the escape and then try to validate. So after which you proceed, you need to design the patch. You see, the patch is not more showing, but in as much as you are seeing design patch, it simply means there's a patch applied on this floor successfully. If I come to this floor and then you notice that there is no patch on this floor. Okay, so over here you can click on the patch design. Let's go to 3D, see something. Okay, get back to the 2D option and then click on this patch again. This will show you the patch on the floor. Okay, that's what I want to show you. All right, like if you come to this floor and then you click on the patch, you see nothing because you have not applied patch on this floor. So get back to this floor and then you have the patch just like this. Now we want to design it. So design patch, click here. Boom, all the patch failed. You see everything red. Wow. Okay, so you know why this is red? It is because we have not designed the reinforced concrete slab. Okay, so now to design reinforced concrete slab, you have to navigate to the design options and then see over here, design slab. Click on it. Boom, you see, all the slab on the floor has been designed. And then you have to know that not only the slab on this floor, all the story slabs is being designed successfully. So now the slab has been designed, and then you can see the reinforcement. If you place the cursor or pointer on the slab panel, you can see the reinforcement generated right there. S12, 250 spacing, T2, T1, you can see generated successfully. And then you can also see the U ratio 0.9 right there. Okay, so now for the patch design, you just have to now come back and then click on this design patch. Click once, boom, see everything as patch design. All right, so this is the right way to carry out your design successfully, the patch, and then as well as the main panel of the floor successfully. If you come to these provisions, and then you just have to come over to review view, or you check this provision, see review view, and then for the slab design, you see, you use this option to check it. You see, this has been designed successfully. Okay, for the slab design, you use that to check. Okay, for the foundation, you use these provisions to check. For the pile, you use this provision to check. You have to take note. I want you to understand this program very well. Okay, if you are, for general design of the structural element, you use here to check, which are the beams right there on the floor. So come over to this floor, and then you come to the review view as well, these provisions, and then you click on this statute. You see this slab has also been designed. The reinforcement has also been generated, as you can see from here. Okay, so we are done with the superstructure. So we go to the substructure, which are the foundations. And I said I will show you how you can design a street foundations. Okay, successfully using this program. So we design a street foundation as well as a pad foundations. So now navigate to the base level. Here is the base level where you actually see the base columns successfully. Okay, so at this point now, I want to start to do the street foundation design. For the street foundation design, we will start by designing the pad footings. Go to the foundation tab right here and click on the pad base. So select there, come to the properties of the pad base. Okay, now you see the AYLS of the pad base is actually given right here. You see, it's actually given. Okay, but this is not a design section. All right, it's not the design section. The depth is given, but that is not the design section. So we go by this concrete class. So we come down, and then everything is almost okay. Very important. Reinforcement loose bar. It's very, very important. Screw down, and then you see the top cover, the bottom cover, the side cover, if there's any, is 40 millimeters right there. And then over here you see we have the soil unit weight. Okay, so if you have your soil informations, you have to provide them here. So for the sake of these presentations, we are going to be using bearing capacity of 200 millimeters. Sorry, 200 kilonewton per square meters and not millimeters. So I have to screw down right here. So before you applied your pad footings or any foundations, you have to key in the bearing capacity, because that is what is going to be used to actually calculate the sections successfully. All right, so everything is good from here. All of these sections, they are just at default. Okay, when it is designed, everything will change to the design sections successfully based on the applied axial load. Okay, so now I want to be applying this pad foundations in some of these provisions. Like I will apply it here. I will just select this, that is the pad being placed. Okay, I will also select this to apply it here. All right, so I can proceed to apply it here, and then I applied it here and here. So these other provisions, I will be using strip foundations. Okay, so you will learn how to properly design strip foundation. Now, okay, so I haven't applied these pad footings. I need to design the pad first before I go into the strips. Okay, so now for the strips, we have to come to, sorry, for the pad design, I'll have to come to this design pad base. I click once, boom, you see the 6 pad base has been designed successfully. I will select it, and then I have to check. Remember, in these provisions, I've checked, you see everything as past design. See, we have checked for punching, shear, we have also checked for sliding. All right, so everything has been checked properly. Okay, we don't have any problem with this part. Everything is good. If you right click and then you also try to design member again, just to see if the section will change, you see everything is intact. All right, all of the design condition has passed successfully. Okay, so I click on the close option. So now we proceed. We want to design the strip footings. For the strip footings, we will navigate to, you can see over here for the foundation, the statute, we use this for the statute for the foundations. Just as I said earlier, for the pile, you use this to check the statute. Okay. All right, so I will right click here and then I go back to the structural view. So here we go. For the strip footings, we go. I will also have to click on the strip. This one, the strips, I select right there. So once you select right there, I have to come into the property of the strip footings and make sure necessary changes. So you see overall depth at default is 200, as the depth of the strip footings is 200. So I can decide to make this 300. All right, it is my own suggestion and settings if that will pass design. Okay, so because we try sections. So over here, you see allowable bearing capacity, we use 200. So I will use 200 in these provisions as well, just like this. So before you place your strip footing, anything foundations, you have to do all these settings are very, very important. Okay, so no, proceed. Over here, I will scroll down, I scroll up, and then you see the concrete class is good. All right, I'm looking for something. Okay, here we go. So the width of the strip footings, the width is this one, is 1000 millimeters. Okay, I will change this to 1300 millimeters, like this, 1300 millimeters. Okay, so now I want to start to apply the strip footings. What you do, pay close attention here. Okay, so now to apply the strip footings, select the first column, just like this. Select the second columns, you see the strip is being applied. Select the third column, you see what will happen here, because it's going to collide with this particular columns right here. So I pick this one as well, I pick this as well, you see I pick this. So I go this way, you see I go this way, and I go this way, you see. So this is how the strip footing is being applied successfully. just like this, and then like this. Then the last one you want to place, you need to double click at the last one. Okay, so I double click right there to have it placed successfully. So this is the type of foundation we have. All right, so now I will click on the validate. You see here it's not validating. You see, if you check here, it's not validating. Model is having problem because I'm having a kind of street footings on a support. This alone, the street footing alone is a support. All right, so it's not supposed to be when there is an existing support. So that is why I'm having this. We'll correct it shortly. Okay, so after modeling it, I try to validate. It doesn't want to validate. Go to 3D. Okay, here we go. So this is our street footings that we just created. You see, this is the street footings. All right, so we want to start the design of this street footing. Before you design this street footing, you need to rerun analysis again, because you just place this. Okay, so the load has not been distributed on it. So it is when you do the analysis, that is when the load from the columns, the axial load, will be distributed on the footings, that you will now have to use it to design the footings successfully in Tekla Structural Designer. All right, so we proceed. Now we go to the analysis tab. So this analysis tab, okay. So now for the street footing, just like when you are designing a kind of when you are designing do I call it flat slab, or when you are designing foundation, a kind of floating raft or slab raft. Okay, this is majorly a slab raft, but it doesn't take care of the whole area of the building. In case of a flat a raft slab, it has to cover the whole area of the building, but this has just covered some part. That is why we call it street footings. All right, so now you need to come to do some settings. Click in that settings provisions, and then over here come to the modification factors. Click right there, and then you see over if it's just down, we have, you see, for the slab, flat slab, you have this. For the mat foundations, you have 2.5. You see 2.5. So this should be changed to 2.5, and or it should be changed to 2. If it's not 2.5, you can go by 2. 2 is also good. It's within the code limit. All right. So after which you click on the save options. From here, click on yes options. Then after which click on the OK options. All right, that is done. Now we will run the analysis again. We use this analysis first, and then we'll also use this one second. Okay, so we click on this analysis. So after some seconds, we are good to go. You can see analysis has been done on this structure. You can see our footings, these three footings right here. So you have to check this using the stressed options. Click on that to actually see where the stressed are much, using the key here to check it successfully. And then you can use this bearing pressure options to actually check based on the plane axial and then other axial forces. Then you see the forces right here on these straight footings successfully. And then over here we also have the bottom, using wood and hammer to also check that. This is just like similar to what we have in Tekla structure. All right, you check that also successfully. Go back to the analysis again, and then you carry out this 3D only statics. Click right there, and that has been done successfully on the street footings. Okay, so having done this analysis, we don't have much thing to check here. We need to proceed to design of the street footings. Okay, so now we can as well navigate to the result right here. And if you check here, you see we have the FHS down, we have the grillage. Okay, all of that has been applied successfully. So we can also check some of these stressed and see the behavior. From the stress, you can be able to read the behavior of the footings successfully, looking at the key right here. All right, so we get it back to the first one, and then here is the area of steel. This is the area of steel. Okay, so this is bottom, and then you see this is top area of steel. They are not much from what you have here. The area of steel in millimeter square, they are not much right here, and then Y bottom. So we are good. So we navigate to the base, at the base, you can still check. If you go to the result right here, you can still check at the base, but we are good now. So before you finally carry out the design of the footing, you need to get rid of the support. You see this pin support, you need to get rid of it, because if you check here, the model is having some warning. Okay, you see, I will have to expand this provision, so you see what we have here. So support exists within area of mat, you see. So now we go to the 3D and then change these provisions to the structural view. Okay, so at this point, you just have to select the support. Try to select only the support. You try to select only the support. You may not be able to select it as fast as that, so you have to position the project in a way that you can select it. If I select all of this, you see the support is selected. You can use the delete options from here to delete it up. Support has been deleted from that provisions. So for these other ones, you can also do a window just like this to select that for supports, and then delete it from here as well. All right, if you do not write analysis, do not remove the support, please. You have to run analysis with the support just like this, and then you delete this. Click on the OK options. So now let's validate this model. See, here it's validated. Click on the save option. Sorry, don't want to use that. Click on this save. Okay, we have not saved this before. We have not saved this before, so let's just save, give it a name. This is going to be given a name as TSD. I will just call it TSD design right here. 1. All right. So I save it in this directory on the desktop. I click on the save options to save this model. Very, very important. Okay. So having saved the model, we now have to design the street footing. So now we navigate to the foundation. You have to design through the foundations, and then you can decide to apply the patch again on this, but we don't need it. What you just have to click on is you click on the design mat. Here we go. You see design mat. You see this has been designed, but it is having some warning right here. If you put your cursor, all the reinforcement has been designed successfully, but it's giving us some warning. Maybe the 3D analysis has not been carried out on the mat as it's supposed. That's why I'm giving out this warning, but that is not a problem, but the reinforcement has been generated successfully. Okay, this has been designed, all right, with a warning. Okay, but if you want to check the warning, you can always select on it, select on the street footings, and right click, and then you can use check slab or design slab again. Click on that. So that has tried to redesign it, and then it is still having the warning. So you right click right here, and then you click on the check slab, sorry, check panel, this option. Okay, so now we have the bearing pressure summary. All right, so over here you see the reinforcement design summary. Everything has been designed successfully, you see over here. But we are having bearing pressure summary. If you select to expand this, you see pressure here has passed, you see. But where we have the little issue is detention warning. Okay, that is detention warning, and then we have 3D analysis, FE test down. So it's because of this had not been properly applied on the foundation. That is why this warning comes up actually. Okay, so now if you want to do that, you want to look at that, you can still get back to the analysis tab, and then click in these provisions, and then you come to this, select these options, you click on the OK, and then you run the analysis again, which I wouldn't want us to go through. All right, so we are good at this point. So now I want to start to produce the drawings of this our designs successfully. Click on the update. All right, to validate the model. So we start from the foundations to produce the drawings. Okay, so now we come to the draw options. In the draw option, you now have to come to settings. Yeah, so in these settings, yeah, there are many things you need to set. Okay, so for the slab and mat, this is the layout. For the beams, you have this. All right, and then for the brace, you have this. For the columns, you have this informations. All right, for the wall, you have this. For the slab mat, you have these informations. So you may leave all of this at default, but I want to show you something that you need to set over here. If you come to the general and then you expand these configurations, you see, expand these configurations, and then you can see that we have a member details right here. Click on the member details. So in this member details, you see some information like concrete beams details over here, and then if you select in these provisions, you have some column details also here. Okay, all of these informations you have to just leave them at default. Okay, I've selected on the member schedule, leave that one to at default, and then we go to where you have the slab and mat. So all of this is what you are going to actually see, okay, in the drawings as you are about to, produce successfully. So come down to this member details again, these provisions, and then you see beam detail. Now in this beam detail, you see the content. Now you see the level, show span level. So these are the things you are supposed to enable. And then for the cross sections, you see first, span. You see position, span only. So you can choose support and span for the cross sections of the beams. Okay, you understand? But this is a span only. Okay, so over here you see first span or span, just the first span only of the beam, you will get the cross section. All right, so this is very important. So for the bar labels, show bar mark in elevation, show steel bar layer informations. All right, this will be shown. For the dimensions, so you see we have the lap, the anchorage length, everything will be applied successfully. For the quantity, show reinforcement quantity. So if you don't need reinforcement quantity during when you are producing your drawing, you will not show this. Okay, you come to the style right here. For the style, you still have you see print beam label below. All right, underlined beam label. So if I check here, the beam label details will not be underlined. All right, so now if I click on the cross sections, I click on the cross sections right here. So you can see how it's going to add beams, names, labels as prefix, so that you can be able to identify the beams on the floors. Okay, so the longitudinal bar, you see, display only a single sidebar in the details. All right, for the stirrup, you have this. For the dimensions, you also have this. Okay, so this is where you can do most of the settings for your detailed drawings. It's very important. I think I've thrown more light. You can find time to go through this and be able to produce and do some settings that you wish to do before you produce your drawings in Tekla Structural Designer. Click on the OK options. All right, so now before we go into drawing fully, I want to show you how you can actually be able to visualize the 3D reinforcement for this design we have just done. So I can click in this provision and get this back to the structural view. Okay, so I want to also inform you we're having a masterclass on this particular program, Tekla Structural Designer. So you can join our masterclass, okay, and then you will learn this program from start to finished, and then you become pro and then stand alone in the use of these programs. Okay, so join our masterclass. We have our link in the description of this video. All right, so let's just make progress. I want to show you how you can actually visualize the 3D reinforcement, both slab reinforcement. I want to show you how you can visualize both slab reinforcement, foundation reinforcement, and the beams and column reinforcement for in 3D. All right, so just like we have a Prota structure, we have Prota detail. All right, so likewise, Tekla structure have Tekla Structural Designer have Tekla structure as its own Prota detail. You understand? So now, if you take this model there, you'll be able to generate that. But I want to show you how to do that shortly. Okay, let's get to Tekla structure. Now, this is Tekla Structural Designer. We are going to Tekla structure. Take note of the name of the model. TSD Design 1, and then it is at desktop. All right. So we navigate to Tekla structure. If I enable Tekla structure, just like this Tekla structure, and then I will go straight away to these options, and then I go straight to where I have import right here, and then Tekla Structural Designer. I want to be importing the model we just designed right away. Okay, so over here, click in these provisions, and then here we go. It takes me to this folder. I will navigate to the desktop where I have models. Okay, so if I check here, I can see the model. The model cannot be shown on the desktop. Okay. So I want to actually text this model from the desktop to this folder, all right, inside the document, so Tekla Structure can be able to actually detect it. All right, so I'll be doing that very fast. So I'll enable this, and then I go to the desktop from these provisions. Okay, I should see the model right here. Where is the model? See this one. This one. I think this is the one. TSD Design 1. Okay, no, this is AutoCAD model. All right, let's check. I can't see this model right here. All right, there's no problem. Let's check in this place. TST Design 1. Oh. All right, that is not a problem. You can just close this, and then let's navigate to Tekla Structure. So this model is actually at desktop, but it's not. We are not seeing it. Okay, I will correct that. Come to save, and then save it as. So over here we navigate to the document, and then we go straight away to this folder in the document, and then we can be able to save this successfully. All right, that is safe. Okay, we get back to Tekla Structure. Good. Click in these provisions, and then let's look for that model T. We have it as T SD Design 1. See, this is it here. All right, so I click on open. So once you click on open over here, what you need to do, you can check in these provisions of rebars, and then you see over here, create rebars axe. Expand this, you see the information there. If you come to the creation options, you see also the information over here. All the information needed are found in these provisions. Okay, so now you see import rebars for beams, columns, walls, slab, and foundation. So if you are actually importing rebars, you have all of these provisions checked successfully. Okay, so now I click on import right here. So we keep the program some second to actually import. So we are waiting for the program to import this. All right, so at this point you have to click on this accept changes. So once you click on the accept changes, you can see this have actually brought the model into Tekla structure rather. Okay, so the import is done successfully. I click on the close option to close this, and then here we go. We have the model in the Tekla structure, just like this. You can see. All right, so if you want to see the rebars, you just do Ctrl+1 on the keyboard. Here we go. Boom. You see. So this is the reinforcement. All right, of the model we design in Tekla Structural Designer. You see both the slab reinforcement, you can see over here, and then where we have at the story one, we are having something like we have over here we have the patch. So you can see the patch reinforcement as a top bar on the reinforced concrete slab. You see this one at the patch, you know, we actually applied it on this particular story right here, and you see this is it. This is the full reinforcement. So you can also produce your detailed drawings using Tekla Structure, just like this. You see, all right, both the foundation reinforcement, the strips reinforcement, you can see everything just like this. So you can continue working on this from here to produce your detailed drawings as well. So this is just like prototype detail, but this is an advance. It's more advanced. Okay, so let us get back to our Tekla Structural Designer. We continue to produce our drawings and report from there. Okay, so we make progress. I will do okay, to get here. All right, here we go. We want to produce the drawings. So to produce drawings for the columns, you can click on the drawings management right here. Okay, so here is the general arrangement drawings. So if you want to produce general arrangement drawings, you just have to use this option for the general arrangement drawings. Okay, so now you can click on add right there. So you see TSD Design 1 general arrangement drawings. Okay, so I click on this particular content. So for the general arrangement drawing, what do I need? I need the part base and the ST base, which is the foundation, drawings ST1 and ST4. So I can select all of this and I can select this, pull it here, select this, pull it here, pull this here, select this one as well, pull it here, click on this, pull it here. So all of this will be created. I click on the OK options, and then over here I can view. Over here I see view drawings right here. I click right here. So I have this general arrangement drawings, and then you see plan, sections, and elevations, and then you see we have a scale of 1:100. I click on the OK options. Okay, you see now the general arrangement drawing is created. You can see the strip provisions. Okay, for the part footings is when we create the part footings drawings, you will have that. Okay, but for the strips, it's being created successfully. So this has nothing to do with the reinforcement. Okay, this is just the plan view of the foundation, the first floor, second floor, and this is the topmost floor, which is the third floor successfully. All right, so now we get back to TSD. Get back to TSD. Okay, so we have done with that. We proceed to other informations. Now, if I click in this provision again, you know, we are creating drawings. If I click in this provision again, I can come to these provisions and select it. And then I look for the beam details. All right. I look for the concrete column details. I see concrete beam. I will go by beam first. I click on add right here. Okay, you see this. All right. So now I click on the content and I move everything from here into these provisions. You know, we always go by group because we have already set the program to group this for us. So I scroll down, I scroll down, I scroll down. There are some that are not group, that is written on group. I'm looking for it. This one. These are on group beams. Take it to this side. We need this one. Groups. Okay. These are the group beams. All right. So now, after which, click on the OK options. And then you can now proceed to click on this view drawing. Click right there. And over here, you see the information as well as the scale right here. Click on the OK options, and then you see all the beams in the structure. We have these few beams groups together. All right, you have this group together just like this, and then you have the sections. So this program will actually minimize your editing effort. All right, it will minimize it successfully. So let's go back for the columns. We click in these provisions and then you select the concrete columns right here. All right, so here we go. Click on add, and then for the content we need to move all of this to these provisions. If we check it right here, you also see on group columns here. On group columns here. All right, there are some that the program was able to group, and there are some that the program was unable to group. You should understand that. Okay, so you see these ones are the one that the program was able to group. You see this one, and then this one is the one that the program was unable to group. So you have to understand, it's very, very important. So click on the OK options. We are moving all. That means we need to move the other beams that was on group as well. Okay, so when we get here, I click on the view, and then you click on the columns right there. So here we go. This is the columns that we have. Some are group and some are not group. The one that are group, you can see this is 3 number. Okay, and then these ones are not group, so you don't have anything on under it. You can see right there. So there are the columns, and you don't have much editing in this. As you can see how neat this column has been produced from Tekla Structural Designer. Nothing to edit. All right, you don't need to bother yourself stressing yourself editing. All right, so from, you see, you connect the foundations. You see, this is the ST base level, and this is the foundation depth, and then from these foundations it takes it to all the way to the roof level successfully and detailed with the sections. Okay, so I get back here again. I want to work on this again. We need some beams here that are not groups. All right, so now if I select on this, I can remove this one. All right, then add again. Okay, click on the content. So if you scroll down, we are producing on group beams. There are beams that the program was able to group. There are also beams. This one are the beams that the program was unable to group. This one, you see, on group beams. So they are part of the beams we need to actually create the detailed drawings. So I click on the view right there. So I have this, click on the OK options. All right, this has been produced before. You understand? This has been produced. That is why it is showing me this. You see, it is showing me this error right here. Okay, you see it here. It has been produced. So let's close this from here. We need to close this from here. First, click on no options. We don't want to save it. Here we go. Now, if you check over here, what is here? All right, this is not. So get back here. So over here, just prefix this with 1. Okay, just like this, change the name so that it will not interfere with the one that has been produced before. Okay, so now come to this content. In this content, move everything this time around to this place. We are producing everything, both the one program was able to group and the one the program was unable to group. Okay, click right here and then click on the okay options. So this, boom, this is created just like this. This is all the beams in the story. There are some that are groups, that are some that are not group. Okay, like the one that are groups. Okay, you will see some prefix right there. You see the beams are very neat. You don't need to edit anything right here. The letters, the informations, the bars, everything is very visible. Okay, so we are good. We proceed to produce more of the drawings. We need to produce the foundation. So come over here and then we click on the isolated, you see isolated details right here. Select that and then click on the add options. So ST isolated, click in this provision. So these are the parts we have. So we have 6, 1, 2, 3, 4, 5, 6. All right, we have 6 in this model. Move this to this provision. So you have this just like this. So if you select the area by level, that is where we go. Click on the OK options, and then we proceed to these provisions, view drawings. So we have the scale right here. Click on the OK options. So here we go. The part we have is just 1. Why is it 1? If you check under here, see 6 number. So this is being grouped automatically. You can see it's being grouped automatically. So we are not having 1 out of 6 right here. So this is the part that we have for this design. You can see we are almost done with all the drawings of this this particular design we have done. Okay, so let's go back to these provisions. What do we need again? We need the foundation plan and then the slab details. But in slab details, you don't need to produce it here. You produce that in Tekla Structure. So you see, just as you learn rotor structure. So this is Tekla Structure. If you want to produce the slab detail, look at the slab right here. You produce the detail from here. Okay, because Tekla Structural Designer may not be able to give you a detail that you will actually like. So you just use Tekla Structure because you can see all the reinforcement is here, as you can see for the slab and as well as the strip footings. So you produce that using Tekla Structure. Okay, let's get back to Tekla Structural Designer. Okay, so I will cancel these provisions. Now we can also be able to go to the plant. If you go to the plan like this and then you navigate to the structural view, you come to the drawings, you will notice that the foundation layout, you see, and the slab layout is prompting here. So you can be able to actually produce this. So we get to the foundations right here. So over here I see foundation layout. You click right there. So from here you can check the scale and everything. If it's okay, click on the OK options. So you see here you now see the footings. You know, the one we created before, which is general arrangement drawing, there was no footings. We only have the strips right here. You can see the strips and the thickness that we have here. All right, and then you can see the foundations, the part footings and the details right here. And then we have only 1 out of 6 being grouped successfully. All right, so we have produced almost all the drawings for this design successfully. Okay, if you have any question, you have to drop it in the comment section. Please like and subscribe to our channel to have more of this kind of presentations and detailed design successfully. All right, we proceed. We want to produce the report. Let's see how to produce the report for the structural element. For the report, you come to the report tab. Okay, then you need to come to the model report. Okay, the model report here, you need to actually specify what you are going to do. Okay, so what we are going to do, what report we need is the building design report. So you select building design report right here and then click on the active. Okay, so once you click on active, and then over here we are having too many things. Move them to this side, move this to this side, come to concrete, expand it, move this to this side, just like this, expand this as well. So here we have the beams, we have the columns, we have the walls. So we don't really need the wall because we don't have walls here. You see how I'm moving them. And then we have the pile, we don't have pile right here. Move them out, move this one out. And then we have the part design. You see, I have this. We have the slab/mat design. I have this as well. You see, and then I have the columns. So if I want to produce all of this at once, I'm good to go. Having selected all of it in this provision of report structure panel, I click on the OK options. So now if I come to member report right here, you see I have concrete beam summary, I have concrete beams design. So concrete beam design over to this side, you see I have drawings, design summary, I have design calculations, all for only beam. So once I'm done with the beams, I can now come to these provisions and select for the reinforced concrete column. Once I'm done with the reinforced concrete column, I proceed to other structural elements, including the substructural elements successfully. Okay, so now let's go by the beams. I have all of these informations for the design. Okay, if you need analysis report, you use these options. This option will give you the end reactions, so it will give you the factors, the bending moment, the shear forces. You'll get them under analysis report. But I'm going by concrete beam design, this one. Okay. Once you click on the OK, the next thing you need to do is just to click on the show report. So once you show report, you give the progress of seconds. So this is going to actually check and then give you the detailed report for the reinforced concrete beam. So in like manner, you are going to get a detailed report for the columns as well as other structural elements successfully. So this is the beams. All right, you see over here, beam design, beam design, and then you see regional code, United Kingdom Euro code. Design code is BS this 2004. You see, so now from here you begin to see the report. There are so much of it right here. You scroll down, you see the report for your design, the reinforced concrete beam. You can also see the detailed report too. Once you come down, continue to come down, there's a provisions that it provided a detailed report along these provisions successfully. So you see over here we have the detailed report for the columns right here. You see the column sections. You see all of that we selected. So if you scroll down as well, you can actually see other structural elements. You see the tables, summary design table for columns. Everything is here. All right, so you can actually be able to print this using PDF, or you can print it in Word. Okay, and then attach it to your design successfully. I believe at this point we have done normal. Okay, so we are going to be stopping here for today, and I would like you to give us a thumbs up. Click on the like button on the channel, and if you have not subscribed to this channel, subscribe to our channel. We bring to you more useful design informations, full video like this in the next presentations. And don't forget to join our channel membership. Okay, we stop here. Have a great day and see you in the next presentations. Bye for now.